Hi everyone, welcome to this practice test on IP routing the LAN. So there are going to be 10 questions in this practice test, so I hope you've been able to study this chapter either through the videos I put out or other resources. So let's get into the practice test. So question number 1 is true or false, show running config and show stop config can be used to identify routed and switched ports. So please have a chance to think about this. If you need to pause the video, please go ahead and do so now, else I will reveal the answer in a few seconds. So 5, 4, 3, 2, 1, 0. And the answer is false. So these commands don't help at all with seeing the routed and switch ports status. So, the question is then, which commands do? So the commands that do, you might remember this from my lesson. So show run config, show stop config, they don't. But show interfaces status, that will list switch ports. Show interfaces description, show IP interface brief, show protocols. These fabulous 4, show interfaces description, show IP interface brief, show protocols. They will show you routed and switch ports. What they don't do is tell you which one is which, but they will show you both. So, question number 2 is true or false. We should use the same number in the command channel-group insert number mode on all interfaces and on different switches too. So we should use the same number in the command channel-group insert number mode on all interfaces and on different switches too. Please, if you need to pause the video now, pause the video, else I'll play the answer in about 5 seconds. 3, 2, 1, 0. So the answer is false. So the number should be the same for all physical ports on the same switch, but the channel-group number can be different on different switches. So the channel group number can be should be the same for all physical ports on the same switch, but it can be different for different switches. Okay, so same for all physical ports on the same switch, but the channel group number can be different for ports on different switches. So question number 3, which switch Cisco IOS command can move the user from global config mode to the correct mode to configure a management IP address that exists in VLAN 200. So is it A, VLAN interface 200, B, interface .1Q200, C, VLAN 200, or D, interface VLAN 200? Which Cisco IOS command moves the user from global config mode to the correct mode to configure a management address that exists in VLAN 200? VLAN interface 200, so A, VLAN interface 200, B, interface .1Q, C, VLAN 200, or D, interface VLAN 200. Please have a think and pause the video if you need to, else I will play the answer in about 5 seconds. Okay, so the answer is D, interface VLAN 200. Okay, so that will move you from global configuration mode to that interface configuration mode so that you can configure the IP address for that interface. So the question number 4, which answer shows the correct configuration for A2.1Q encapsulation on a router subinterface for VLAN 10? Which answer shows the correct configuration for A2.2.1Q encapsulation on a router subinterface for VLAN 10? So you've got A, B, C, and D. Please, I'd recommend everyone to pause the video, read through them, and I'll play the answer in about 5 seconds. Okay, so 5, 4, 3, 2, 1, 0. So the answer is C. And you got to remember, when you're configuring a router subinterface, right, for VLAN, configuring encapsulation, there's basically 3 things you need to enter, okay? And this one is the complete configuration of that, whereas the others, they don't have the necessary elements to it. So they are all incorrect. This is the only incorrect one. So interface VLAN, then you specify the interface and the sub interface, then encapsulation.1Q10. Okay, encapsulation.1q10, specify that VLAN there, and then the IP address. So you type in IP address, then you actually write out the IP address, and then you write out the subnet mask in DDN, that's decimal notation. Now, this is the only answer that actually had all those three in there completely. Whereas others, like here, you've got the subinterface specified there. You got subinterface here. This first line is all correct, but then the second line of commands is wrong. You don't configure like that. At third line, it was correct, but the problem here is with that second line. The problem here is that it completely misses out encapsulation.1q10. You don't have that second line there. There's no encapsulation being configured for that VLAN, so that can't be right. And D nearly got it all, nearly had everything, but it was configured on a physical interface. You don't do that. You configure on a sub interface. So this is why C was the only correct answer there. Right, question number 5. So refer to the exhibit below, which shows output taken from a router. Which answers describe correct conclusions about the two interfaces. So referring to this exhibit below, which shows output taken from a router, which answers describe correct conclusions about the two interfaces. Okay, so A, of the two interfaces only, so let me quickly read out the exhibit. So VLAN 50, interface gigabit Ethernet 015, 0/1/5, switchport access VLAN 50, interface VLAN 50, IP address 10.10.10.1, 255.255.255.0, interface gigabit Ethernet 0/0/0, IP address 10.10.40.1, 255.255.255.0. Okay. All right, so you got some output here. Which answers of these 4 describe correct conclusions about the two interfaces? All right, so there's 2 correct answers. You need to choose 2 answers of these 4. So A, of the two interfaces, only G000 is a routed interface. B, of the two interfaces, only G01015 is a routed interface. C, of the two interfaces, only G000 is a switched interface. D, of the two interfaces, only G015 is a switched interface. Got 4 answers here. So please pause the video and have a think, and I'll play the answer in about 5 seconds. So please pause the video now. Okay, so I hope you had a chance to think about that. I hope you had a chance to think about this. And the answer is the answers are for this it's B. So okay, sorry, not B. The answers are D. So of the two interfaces only, G015 is a switched interface. D. And A. So okay. So interface, so that's first interface that you're seeing here, G015, that's a switched interface, okay? You're seeing VLAN configuration there, okay? That's something you're not going to, right? You can't use that command, switchport access VLAN 50. You wouldn't use that on a router. That's something that you would use on a switch. So, and interface gigabit Ethernet 000, it's not, okay? So 015 is a switched interface. And interface gigabit Ethernet 000, that cannot be that you've got an option here, routed or switched interface. But we can only see an IP address configured here. We don't see any VLAN configuration. So that really is telling us that this is that's a routed interface. So so for the next question, so here's an explanation. Okay, so that was sorry, that's for the previous answer here. Okay. sorry, that's gone a bit muddled there. That was actually this. Ignore that bit. That's for 4. Question 4. Question number 6. So the diagram here shows a design that uses a 4-link layer 3 ether channel. 4-link layer 3 ether channel. Which answers list interface subcommands with appropriate settings for the physical interfaces on switch New York City switch 001 that are part of this ether channel. So this diagram below shows design that uses a 4-link layer 3 ether channel, which answers lists interface subcommands with appropriate settings for the physical interfaces on switch New York City switch 001 that are part of this ether channel. A, switch port, no, B, no switch port, C, IP address 10.10.10.10, 255.255.255.0, and D, no IP address. So which answers are listing interface subcommands with appropriate settings for the physical interfaces on switch on switch NYC switch SW001 that are part of this ether channel? Which answers are listing interface subcommands with appropriate settings for the physical interfaces on switch NYC SW001 that are part of this ether channel? A, switch port, B, no switch port, C, IP address 10.10.10.10, 255.255.255.0, D, no IP address. So which of the 4 are listing appropriate settings for the physical interfaces? So, and there's two correct answers in here in this for this question. Sorry, I've not written that, but that's 2 correct answers. You need to select 2 of these. So please have a think about this. I'll give yourselves about 10 seconds. Please pause the video if you need to, and play the answer when you're ready. Okay, so 5, 4, 3, 2, 1, 0. Okay, I'm going to real answer, so I hope you've had a chance to think about this. So the correct answers are B and D. No switch port, no IP address. Those are commands that you'd use in that configuration. Remember that the configuration for each channel is very, very similar to layer 2 on when you configure layer 3 each channel, but there's a key difference. There's something that we do extras, that we enter no switch port, and no IP address is something that we can also use. Okay, so no switch port and no IP address. That's what we do. Okay, because we need to turn the port into a routed port, and no IP address is something that's another parameter that we can use as well for this configuration. So those were the correct answers, B and D. B and D. Okay, so just a little bit about no IP address. So we've got to remember that iOS, in fact, it adds the no IP address command to the interface when the no switch port command is configured on interface. iOS will add the no IP address command to the interface. Okay, so that's something important there to know. Okay, so no IP address. Okay, and that's also just to mention about, that's used for clarity when others view the configuration. Okay, the physical port doesn't need an IP address, so configuring the no IP address command is useful for clarity when others other administrators view that configuration. So question number 7, which of the following statements are true about layer 3 ether channel? So select 2 answers. So A is optional to configure the channel-group command on the physical interface. B, iOS automatically adds the no IP address command when the switch port command is configured. C, iOS doesn't add the no IP address command when the no switch port command is configured. And D, the no switch port command enables a routed port. Okay, there's 4 things there. So quite lucky if because this question is very easy. There's two things there. One of these things I've actually talked about, so that's kind of given one of the answers away. But there's still another thing that you need to choose. So please have a think and pause the video and then play when you're ready. Okay, so 5, 4, 3, 2, 1, 0. So the answer is B and D. Okay, so yeah, I did mention this, so I already gave that away, but nevertheless, it's very important to know about that. So I don't mind helping you a little bit on one of these. There's still another one that you need to choose. So iOS automatically adds the no IP address command when the no switch port command is configured. But the other part of this, of the puzzle, so you need to remember the two answers. The no switch port command, okay, that enables a routed port. Okay, so the switch port, the no switch port command enables a routed port. Sorry, this that does not make sense. That wasn't really worded well. The no switch port command enables a routed port. Okay, so that's the other thing that we need to remember. So, question number 8, what command can you use to verify an Ether channel configuration? A, display Ether channel summary. B, show Ether channel. C, show Ether channel brief. Or D, show Ether channel summary. Please have a think and play the answer when you're ready. 5, 4, 3, 2, 1, 0. So, the answer is D, show Ether channel summary. That's what you use to view Ether channel configuration. Question number 9. It's quite a big question, so I'd definitely recommend everyone to pause this video. But let's read it out. So then, in the figure, you've got here. What we've got is, I'm just going to explain the figure in my own words first. But in the figure, sorry, in the figure, what you see is two hosts. You see a router and a switch. Okay, so you see two hosts, router and a switch, and you have VLAN 1. So host 1, sorry, is connected to fast Ethernet 0/1 port fast Ethernet 0/1. It's configured in VLAN 1. Host 2 is connected to fast Ethernet port 0/2, configured in VLAN 2. And then you have the router and the switch connected to over a trunk link. So, okay, fast Ethernet 0/0 on the router end, fast Ethernet 0/0 on the switch side. Those are the two Ethernet ports there, fast Ethernet ports that and the trunks configured over them. So in the figure, host 1 is in VLAN 1, host 2 is in VLAN 2, router 1 R1 is using 802.1q trunking and the default native VLAN. R1 has an IP address associated with both VLAN 1 and VLAN 2 as shown. So you've got these on the side, you've got VLAN 1, 10.1.1.254, 255.255.250, and VLAN 2, 10.1.2.254, 255.255.255.0. Host 1 and IP address and host 2's IP address are there listed. So R1 has an IP address associated with both VLAN 1 and VLAN 2 as shown. So when you consider only the traffic that flows in both directions between host 1 and host 2 and no other traffic in the network, which of the following is true? A, frames that switch 1 forwards out fast Ethernet 0/1 to host 1 have a VLAN 1 tag in front of the normal Ethernet header. B, frames that switch 1 forwards out of fast Ethernet 0/2 to host 2 have a VLAN 2 tag in the front of the normal Ethernet header. C, after switch 1 receives a frame from host 1, switch 1 forwards the frame out of fast Ethernet 0/22 to R1. This forwarded frame has a VLAN 1 tag in the Ethernet header as it exits switch 1's fast Ethernet 0/22 interface. And D, after switch 1 receives a frame from host 2, switch 1 forwards the frame out of fast Ethernet 0/22 to R1. This forwarded frame has a VLAN tag in the Ethernet header as it exits switch 1's fast Ethernet 0/22 interface. So there's four answers there. There's only one correct one. Please have a think. I'll give yourselves 10 seconds to pause the video and then play the answer, please, when you're ready. 5, 4, 3, 2, 1, 0, and the answer is D. The answer is D. So why is the answer D? Well, that's the key thing. So I did accidentally kind of reveal the answer earlier, but the key thing is not just to see the answer, is to know why. Okay, so apologies, I made that little mistake there, but the answer is D, and the reason is, I'll tell you. So if you look here at this figure again, let me we look at the figure. Look, host 1 got host 2, router 1, switch 1. Okay, now the correct answer is that switch 1 receives a frame from host 2, switch 1 forwards the frame out of fast Ethernet 0/22. That forwarded frame will have a VLAN 2 tag in the Ethernet header as it exits switch 1's fast Ethernet 0/22 interface. Now, why can't it be the other as well? A, frames that switch 1 forwards out of fast Ethernet 0/1 to host 1. So that's fast Ethernet 0/1. You've got, all right, fast Ethernet. Okay, so frames that switch 1 forwards out of fast Ethernet 0/1, this port here, to host 1, have a VLAN 1 tag in front of the normal Ethernet header. Now, if switch 1 is forwarding to host 2 out of that port, you can't have that. Firstly, this port, that's an access port. It's an access port. Same thing here. VLAN frames that switch 1 forwards out of fast Ethernet 0/2 to host 2 have VLAN 2 tag in front of the normal Ethernet header. So if this is saying that this switch is forwarding frames out of that port there to VLAN to host 2. But the problem is VLAN 2 fast Ethernet 0/2. That also is an access port. There's no trunk. It's not a trunk port. It's an access port. Okay, these are both connected to host devices. Those both are access ports. We're not going to use those ports. Those ports aren't going to be forwarding. Okay, so this. Okay, so that's an access port. Host 1 is an access port. Host 2, this port is an access port. Okay, so frames that are sent to it won't be tagged. Okay. Now, question C is also incorrect because switch 1 is receiving a frame from host 1, sending out to this port here fast Ethernet 0/22. The forwarded frame can't have a VLAN 1 tag in the Ethernet header as it comes out of this interface. Why? Because if you look here, router 1 is using HTTP trunking and the default native VLAN. So we can't be sending and look, so VLAN 1 here is the default native VLAN. We've got to remember about the native VLAN is that that's the only VLAN there which untagged frames can be sent through. So then by default, we can't be sending any tagged frames over VLAN 1. So that is also incorrect. D is the only correct answer. VLAN 2, that's not the native VLAN. That can send tagged frames. You can send tagged frames over that VLAN, but you can't send it over VLAN 1. Or VLAN 2, that's fine. So that can be true. That is true, and that's the correct answer. Okay, so VLAN 2 is not the native VLAN. Switch must tag it on a trunk. Okay, remember, it's about the trunk there. Okay, those were access ports. Okay, VLAN 1 is the native VLAN. You can't set frames over the native VLAN, but that is not the native VLAN. You do need to tag that any frames that are going over this any frames that are going to out of this interface to router 1 over that trunk. They will need to be tagged. So that is true. Okay. But all the answers were incorrect. So Question number 10. Which switch IOS command is used on this router's Ethernet subinterface to associate it with VLAN 500? So A, VLAN 500, B, encapsulation W1Q 500, C, switch port access, VLAN 100, D, encapsulation 500. So which command, IOS command, is used on router's Ethernet subinterface to associate it with VLAN 500? A, VLAN 500, B, encapsulation W1Q 500, C, switch port access, VLAN 100, D, encapsulation 500. Please take a moment, have a think, pause the video, and play the answer when you're ready. Okay, 5, 4, 3, 2, 1, 0. The correct answer is B. Okay, so that is what you're going to use. You need to configure encapsulation on that subinterface in order to associate with that VLAN 500. Okay, all the other answers are incorrect. And this is a bit more of an explanation. So when route owning or stick is configured on a router, the encapsulation command is used on a router's Ethernet subinterface to associate it with a specific VLAN. In this case, to associate subinterface with the VLAN 500, the encapsulation .1Q 500 command would be used in subinterface configuration mode. And so that brings me to the end of this practice test. So thank you so much for watching. I do apologize, there are a few little mistakes in this practice test in wording the question or accidentally revealing answers, but it's something that I've not done very much, so I'm kind of, it's still a bit of a learning curve for me. So thanks for bearing with me there. But there were 10 questions. Hope you found the practice test useful, and please join me in future videos. So thank you so much for watching, and take care everyone. Goodbye.